Coming to the next operation, that is to push the registers onto full stack using STMFA. So in these examples, what we are seeing is in example 3 and example 4. So how actually we can perform push operation to full ascending stack and to empty ascending stack. That is what we are discussing in example 3. Okay, that is full ascending stack we'll discuss. In example 4, we'll see how to perform push operation to empty ascending stack. Followed by that, we'll see a sequence of pop operations while considering full descending stack and full ascending. Similarly, empty descending and empty ascending stacks. So coming to this example 3, this is what the precondition we have considered. So R1 is having value 2, R4 is initialized with value 3, and this is the stack pointer status. So that precondition is specified in this diagram. You can observe SP is having the initial value as 8 followed by 30C. Okay, that means since it is a full stack, SP is pointing to the last element inserted. Okay, and we need to perform push operation using this instruction STMFA SP not comma R1 comma R4. So this is the instruction that will be executed. Once this is done, what will be the contents of the memory that we'll see. Okay, you can just observe since it is full ascending stack, first the stack pointer is incremented and then the data is inserted. And you can see since it is ascending stack, the stack is growing in the order of increasing memory address. So since it is growing in the order of increasing memory address, can anyone tell what will be the data at the address 80010? What data you'll find at address 80010 and what address you're going to find at address 80014? So since it is full stack, we'll increment stack pointer and then the data is inserted. That is the push operation is performed. Okay. And how the stack is growing? It is in the order of increasing memory address. From lower address to higher address, we are accessing the memory. So first, which register content will be pushed onto the stack?
R1.
Very good. It is R1. Just remember this general concept. If we are moving from lower address to higher address, it is from lower register to higher register, accessing takes place. If you are moving from higher address to lower address, it is from higher register to lower register. Okay. So the same thing holds for memory. If you are accessing from higher address to lower address, then whatever the first data that is fetched, that will be stored in the higher register. And the next consecutive data, whatever you fetch, it will be stored in the next lower registers. Okay, so same thing holds for registers as well as memory. As in this example, since it is full ascending stack you are using, the first stack pointer is incremented and then the data held in R1 register is saved at the address 80010. Then again stack pointer is incremented by 4. At 80014, the next data that is held, which is held in R4 register, that is saved. Okay. So then if you see the final content of stack pointer after execution of STMFA instruction, what is the content you will see? It is 80014. So that is the post condition you can observe. Since R1, R4 are source registers, their content will not be altered. And coming to the stack pointer, since not symbol is given, it is going to affect the stack pointer register. So after execution, this is what the final content you will find in SP register. It is 80014. So this condition you can see in the memory map here. Coming to the memory, as you told, first in this location 80010, R1 register content is stored, that is 2H, and in 80014, R4 register content is same. So that is what we are seeing in the memory map. And final status of SP is just observe, it is pointing to the last element inserted. Okay, if it were to be full stack, remember in general, if it is full stack, after you perform push operation, what you will say is before you perform, it will be pointing to the last element inserted. And once you perform push operation, SP will be pointing to the last element inserted. There is a new data, whatever you pushed onto the stack. Okay, so this is STMFA instruction. That means full ascending stack you have considered, and we are seeing the push operation where we have considered two registers whose data we are trying to save onto the stack memory. Okay. Coming to the next example, that is to push the registers onto empty stack using STMEA. So this is empty ascending stack we are considering and we are trying to perform the push operation. So let us see the precondition first. The R1 is having the value 2, R4 with value 3, and SP is initialized with value 8000C, and this is the precondition as per the values whatever we have taken. You can observe SP is pointing to 8000C, and you know that since it is empty stack, stack pointer is pointing to the next location after the last element is inserted. Okay, and it is ascending stack. That means the stack grows in the order of increasing memory address. So now we need to perform the insertion operation, that is a push operation. So what is the first operation performed? Since SP is already pointing to the empty location, so first the insertion operation takes place and then the pointer will be incremented. Since it is ascending stack, whenever you perform push operation, stack pointer gets incremented, then data gets inserted, and again stack pointer gets incremented. So after execution of the instruction STMEA SP0, R1, R4, what will be the content of SP? So it will be 80014. So how it is 80014? So first data gets inserted, and that is at the address 8000C, and since it is moving from lower address to higher address, it is ascending stack that is taken. R1 register content will be saved to the address 8000C. So then SP pointer gets incremented. Then R4 register content gets saved to the address 80010. So after that, stack pointer gets incremented by 4. So what is the final address in stack pointer? You'll see it is 80014. And at the address 8000C, what you'll see is R1 register content, and address 80010, what is the data you're going to see? It is R4 register content. Okay. That's what you're seeing in this memory map. Any point of time, if you just check SP, it will be pointing to the next available location after the last data is inserted. If it were to be an empty stack. So ascending stack meaning to perform push operation will be incrementing the stack pointer. So if it were to be descending stack, stack pointer will be decremented when you perform push. So whether first you'll perform increment and after that you're going to insert, or vice versa you're doing, that depends on whether you have taken full stack or empty stack. Okay. Moving on to the next examples. So this 4 examples what we discussed, that is to show you how actually push operation works. So now we shall discuss the pop operation, for which we will be making use of load multiple instructions. Okay. So first we shall see how to make use of pop operation for full stack by using the instruction LDMFD, load multiple full descending. So for this case we have taken full descending stack. How actually it works, we'll see. This is the precondition we have considered, where R1, R4 are initialized with 0. Since it is fetch operation from the memory, after execution of LDM instruction, we will be seeing what will be the content of these two registers, R1 and R4 register. And SP is initialized with 8000C. Okay. And these are the memory contents. At 8000C, it is the data 1 store, and 80010, it is data 2 store. Just observe where SP is pointing to. This is the address 8000C. It is full stack. Okay. So full stack means SP will be pointing to the last element inserted. Now we need to perform the pop operation from the stack. Okay. And that too, it is descending stack. So this is descending stack. Okay. And here we are trying to perform descending means you should know while performing insertion, we are decrementing the stack pointer. That is push operation I'm talking about. If the stack is descending stack, when you perform push operation, we need to decrement the stack pointer. Vice versa operation you are going to perform when you go for pop operation. Okay, so as you can see in this example, just see when you want to perform the pop operation, we are moving from lower address to higher address. Right? This is how pop operation is performed in descending stack. Okay. So what is the operation performed? Already SP is pointing to the element to be deleted. First the data is deleted, and then we need to increment the stack pointer. So in case of push, we were decrementing the stack pointer, but since it is pop operation, we need to increment the stack pointer. Okay. So what is the data that is fetched? That is the data fetched at address 8000C, that is value 1, to which register it will be stored. So since we are moving from lower address to higher address, the first data fetched that will be stored in R1 register, and the next data whatever you fetch that will be stored in R4 register. So After execution of this instruction, that is LDM okay, full descending is the addressing mode we have considered, SP naught, comma, R1, comma, R4. So once you execute this instruction, what will be the final content of SP and what values R1 and R4 registers are going to take? So anyway, since it is full stack, SP is pointing the last element inserted. Just fetch the data from this address. Okay. So let me just write it. So first, this data is retrieved wherever SP is pointing to, and that will be stored in R1 register, since we are moving from lower address to higher address. Then stack pointer is incremented by 4. Then next data, whatever we fetch from the next higher address, that will be stored in the next higher register, which is R4 in the instruction. So after that, stack pointer will be incremented by 4. Okay, so that the SP will be pointing to the next data that is to be removed from the stack. Okay, at any point of time, if you just check SP, it will be pointing to the element that is to be removed, the first element to be removed from the stack. So if it were to be full stack, correct? So just see the final output. What will be the status of SP? It is 80014. This will be the content of ESP. And what will be the contents of R1 register and R4 register? It is 1 and 2 respectively. So that's what we are seeing in the post condition. The R1 is having the value 1, R4 is having the value 2, and SP is having the final address as 80014. So since memory it is the source operand, it will not be affected. It remains the same. So we are just taking the copy of that location and we are transferring it to the registers R1 and R4. So after execution, if you see the content, it remains the same. So 8000C and 80010, these two locations will be having the same data, whatever you have taken in before execution of LDMFD instruction. So that's what you are seeing in this memory map. Just observe SP content. It is 80014. And these locations, that means the empty means we have already popped the data from this memory location. That means physically this data will not be deleted from the stack. Just to show you that these data are already accessed, they are actually invalid data, no more they are stack data. Just to represent that, here we have taken the status as empty. But if we go to those locations, it will be the same data, 2 and 1 stored at 10H and CH locations. Okay, so these are invalid data. Already they are accessed, no more they are stacked data. So whatever you find after 80014, beyond that, that are actually stacked data. Okay, that is the meaning. Coming to the next example, to perform the pop operation from empty stack using LDM-ED. That means empty descending. This is what the type of stack we have taken. Okay. These are the three conditions. R1 and R4 initialized to 0, SP with C. And these two memory locations are having the data. That is 10H is having the data 2 and 14H is having the data 3. And it is empty stack. You know, empty stack means where SP will be, it will be pointing to the next location after last element is inserted. It is descending stack. Okay. So each time you want to perform the push operation, we need to first insert the data and then we need to decrement the stack pointer. Remember, descending means we need to decrement while performing push operation. What we are discussing is pop operation. So for which, what is the, since SP is not pointing to the data that is to be retrieved, so first we need to increment the stack pointer. Okay, since it is empty descending, go for incrementing the stack pointer and then go for deleting the data. Okay, so how to do it? SP, initially it is 800C, then how actually we are updating SP, just go for adding 4 to it, SP plus 4, so that SP is having this address and the data that is fetched from this address, it is stored in R1 register. After execution of the instruction, that is LDM ED, this is the addressing mode we have considered, SP not comma R1 comma R4. So after execution of this instruction, whatever the data that is fetched at address 80010, that will be stored in R1 register. Why R1? Since we are moving from lower address to higher address, so the first data fetched is stored in R1 register and then SP will be incremented by 4. The next data that is fetched, that will be stored in R4 register. So after that, what will be the status of SP register. So first what we have done, we have incremented SP and then we have accessed the data. Then again we have incremented SP and we have accessed the data. So this is increment before addressing mode that is used, the equivalent addressing mode. So that's why the final status, if you just check the SP content, it will be 80014. R1 content will be 2, R4 content will be 3, and SP content will be 80014. So this will be the status. Memory locations, it will remain the same, but in the diagram we'll show it as empty since it is no more the stack data. Okay, so this is the memory map. Hope it is clear. Just observe the final status of SP. It is 80014. SP will be always pointing to the next location after the last data is inserted, since it is empty and also it is descending stack. While push, we'll decrement the stack pointer. Since it is pop here, we are incrementing the stack pointer. Kindly note these differences with respect to each of the addressing modes. So depending on whether it is a full or empty stack you have taken and whether it is ascending or descending stack you are choosing, stack pointer will be updated. Okay. Come to the next example, that is to pop the registers from full stack using LDMFA. It is full ascending. Okay, these are the preconditions. R1, R4 are 0 and SP is having this data. Memory locations 10H and 14H are having the data, that is 2 and 1. Okay, and just observe it is full stack. That's why SP is pointing to the last element inserted. You can observe 80014, and we are trying to perform the pop operation. It is ascending stack. Ascending means while performing push operation, we would have incremented the stack pointer. But here, this is pop operation we are discussing. That means already SP is pointing to the last element inserted. We need to first delete the data or retrieve the data from wherever SP is pointing to, and then we need to decrement the stack pointer by 4. So just observe how actually we are accessing the memory. It is from higher address to lower address. We are trying to access the memory. So whatever the first data that is fetched, okay, from wherever SP is pointing to, that will be stored in which register? It is R4 register. Yes or no? Correct? See, R4 register. And after that, we are going to, this is decrement after. The equivalent instruction is decrement after. Since access the data first, then go for decrementing the stack pointer. Okay. Next data, whatever you access, this will be stored in R1 register. Then decrement stack pointer. Okay. The equivalent addressing mode is, it is DA. Decrement after. Correct. So this is the addressing mode. So just observe what will be the final status of SP. It is C800C. After execution of this LDM instruction, post conditions, we can observe R1 is having 2, R4 is having the value 1, right? And SP is having the final status as 8000C. Coming to the memory locations, since it is source, no change. But in the memory map, what you'll see is empty, indicating that it is no more the stack data. So whatever you find below SP, so all those locations are actually the stack data. So whatever may be the base address for the stack, starting from that base address till wherever SP is pointing to, so all those locations, what they contain is the stack data. So after SP, whatever you find, it is not invalid data. They are not the stack data. Okay. Coming to the next, and here it is full ascending we have used. Just observe how actually we are accessing the stack for performing the pop operation. That's what you have to analyze in this example. Coming to the last example, that is to pop the registers from empty stack using NDMEA, that is empty ascending stack we have considered. So this is the precondition we have taken. Just observe SP is pointing to the empty location, that is to the next location after the last data is inserted. Address is 80014, and memory locations C and 10H, they are having the data 2 and 3. So since these locations are relevant to us, only those memory location status we have specified in the precondition. Okay, and this is the instruction we are trying to execute: LDMEA ESP not comma R1 comma R4. So that means we need to perform the pop operation. Once you see LDM, just remember we are trying to perform the pop operation. So if you use SP register, you should get, and just observing the addressing mode and SP register, you should know that this is one of the stack operation you are trying to perform. That too in specific, it is the pop operation you are trying to perform. Okay. And here you can see in the precondition diagram, SP is pointing to the empty location. So what we have to do is we need to decrement SP. Since it is empty ascending stack means while performing push you would have incremented, while performing pop you have to decrement. So just observe what are the steps to be taken. For performing successive pop operation, two pop operations are performed since two registers are involved in the instruction. Starting from wherever SP is pointing to, we need to proceed with the pop operation. But anyway, since it is empty stack, SP is pointing to the empty location. So first we'll decrement SP by 4. So this is decrement before the equivalent addressing mode for EA, okay, with respect to LDM instruction. Just observe decrement and then access the data. So first data accessed, just observe from where to where we are moving. We are moving from higher address to lower address. So first data that is fetched, it will be stored in R4 register. Then we'll decrement SP by 4. The next data that is fetched, that will be stored in R1 register. Okay, this is decrement after. Sorry, what is the? It is decrement before, not after. It is decrement before. Correct. So first we'll decrement and then we are going to fetch the data. The equivalent addressing mode for EA with respect to LDM is DB, decrement before. So SP is pointing to this empty location. We'll decrement SP by 4. We'll access the data that is stored in R4. Next, we'll decrement SP by 4. At whatever the data stored at address 8000C, that will be fetched and it will be stored in R1 register. So if you just say the final content of SP, it will be 8000CH. And contents of R1 and R4 will be 3 and 2 respectively. See the memory map. Okay. SP is pointing to 8000C. That is all. These two data are already removed. And observe the final status of SP. It is pointing the next available location after the last data in the stack. So this is the last data at address 8008. Beyond that, to the next location, SP will be pointing to. Okay. So this is how the stack operations work. Hope this is clear. Have you all followed? Given with any question, are you able to do it on stack?
Yes,
Is this
ma'am.
clear? Okay.
Yes, ma'am.